In this video, we'll practice how to find powers of integers, large powers of large integers. Okay, so this is an example, 101 to the power 4. How do we solve this? Pause the video, take your time, think about it. Because we're dealing with binomials, it's better to break this apart into two parts. 101 can be neatly broken down into 1 plus 100. 1 plus 100 to the power 4, well, this is very similar to 1 plus x to the power n. We can use that to expand this. So let's do that. 1 plus x to the power n here is 4, so we can first write down the coefficients. We have 4c0, 4c1, 4c2, 4c3 and 4c4. And because there's a plus sign here, all the coefficients are added, plus, 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 plus. Now if you're forgetting what the rest of it is, here's a quick recap of what 1 plus x to the power n is. So its expansion is actually nc0 x to the power 0 plus nc1 x to the power 1 plus nc2 x square and so on. 0, 1, 2 and so on, and the powers are also increasing. X to the power 0, 1, 2 and so on. This goes to ncn x to the power n. And what's x here? X here is 100. So let's put that down. The first term will be 4c0, 100 to the power 0. Then we have 100 to the power 1, 100 square, 100 cube, and then finally 100 to the power 4. This is the binomial expansion of 1 plus 100 to the power 4. Now let's simplify. 4c0 is 1, 4c1 is 4, 4c2 is 6, 4c3 is 4 again, and then 4c4 is 1. Adding all of them up. Okay. 100 to the power 0, well that's 100 to the power 0. It's actually 1. Then we have 100 to the power 1, 100 square, 100 cube, and 100 to the power 4. Okay, so how do we add this up? Well, let's look at the smallest number. We have 1 here. So let's start with 1. Then we have this one. This one's actually 400. So 4 and 2 zeros. So if you put this here, you'll have 1, 0 and 4. 4 and then 2 zeros. So these two are added. They give us 401. Then we have 6 and then 4 zeros. So let's do that. We'll have 6 and 4 zeros. So 4 zeros and 6. So all these three are added. Now let's add 4 and then 100 cube, that's 6 zeros. So 4 and then 6 zeros. 1, 2, 3, 4, 5, one more 0 and then 4. And then finally we have 1 followed by 1, 2, 3, 4, 5, 6, 7, 8 zeros. So 4, 5, 6, 7 and then 8 and then 1. This is the sum of all these 5 terms, which means this is equal to 101 to the power 4. Alright. Now to get a hang of it, let's solve one more. We have 102 to the power 5. Pause the video, think about it. Okay, we can break this down as 100, 100 plus 2 to the power 5. A plus b to the power n. And here's the formula for a plus b to the power n. This is the expansion. It's summation k equals to 0 to n, nck, a to the power n minus k, b to the power k. So if we put a as 100 and b as 2, this is what we get. K equals to 0 to 5 because n here is 5. 5ck, 100 to the power 5 minus k, and then 2 to the power k. And we can do this other way around as well. A doesn't have to be 100, a could be 2. And then in that case, b will be 100. Okay, so let's now expand. 102 to the power 5, that's 2 plus 100. Let's flip this. 2 plus 100 to the power 5, that's equal to k equals to 0 to 5, summation 5ck, 2 to the power 5 minus k, 100 to the power k. The one that we just wrote and this one will give the same answer. You can pick either one. We'll pick this one. Alright, let's write the coefficients. 5ck, k equals to 0 to 5, so we'll have 6 coefficients. 5c0, 5c1, 5c2, 5c3, 5c4, 5c5. Let's actually write down the values of these coefficients as well. 5c0 is 1, 5c1 is 5, 5c2 is 10, 5c3 is also 10, 5c4 is 5, and 5c5 is 1. Alright, now let's look at the powers. we'll take the first one as 100 to the power k. So when k equals to 0, this is 100 to the power 0. Then we have 100 to the power 1, power 2, power 3, power 4, and power 5. And what about 2? Well, 2 has decreasing powers. The first one will be 2 to the power 5, and then 2 to the power 4, 3, 2, 1, 0. All right. Now we multiply these three to get the first term, these three to get the second one, and so on. We'll get all 6 terms, we'll add all of them up, and that's the answer to 102 to the power 5. So let's do that. What do we do next? Let's look at the powers. 2 to the power 5 is 32, then 16, 8, 4, 2, and 1. All right. So multiplying 1 and 32 will give us 32 times 100 to the power 0. Well, that's 1. So 1 times 32, that's 32. Then we have 5 times 16, that's 80. 80 times 100, that's 8,000. Then we have 8 times 10, again 80. Times 100 square, that's 4 zeros. So 80 and 4 zeros, which means 8 and 5 zeros. 8 followed by 5 zeros. Then we have 40 followed by 6 zeros. So 4 followed by 7 zeros. 10 followed by 8 zeros. So 1 followed by 9, and then 1 followed by 10 zeros. Adding all 6 of them will give us 102 to the power 5. So let's do that. We have 1 and then 1 and 0, 4, 0, 8, 0, 8, 0, 3, 2. That's your answer. So this is the fifth power of 102. Let's wrap this up by solving one last problem. This time we'll go below 100. We'll have 99 to the power 4. Pause the video, try this out. Okay, so you can do this as 100 minus 1 to the power 4 or 1 minus 100 to the power 4. Because this is an even power, you can have anything inside it. 100 minus 1 will give the same answer as 1 minus 100. And I like 1 minus 100 more because this is very close to 1 minus x to the power n. All I need to do is now expand this and plug in x as 100. What's the expansion for 1 minus x to the power n? Well, that's equal to nc0 x to the power 0 minus, don't forget the alternating plus minus signs, nc1 x to the power 1 plus nc2 x square minus nc3 x cube, and so on up until the last term. All right, so let's do that. N here is 4, so we have 4c0, 4c1, 4c2, 4c3, and 4c4. Don't forget the alternate signs. The first one is positive, then negative, plus, minus, plus. Now the value of x here is 100, increasing powers of 100. This is 100 to the power 0, 100 to the power 1, power 2, power 3, and power 4. Now let's simplify. 4c0 is 1, 4c1 is 4, 4c2 is 6, 4c3 is 4, and 4c4 is 1. Alternate signs. Now powers of 100. 100 to the power 0, power 1, power 2, power 3, and then power 4. How do we do this? 3 terms are added, 2 terms are subtracted. Let's take the additions first. This is 1, this is 60,000, yeah. And this is 1 followed by 8 zeros. So let's write this one down first. Add this to 60000, 60,000, and then add 1 to it as well. So these 3 terms added minus these 2 terms subtracted. So this is 4, 1, 2, 3, 4, 5, 6. 4 followed by 6 zeros, and then 4 followed by 2 zeros, that's 400. Left side is 1000600001 minus right side is 4000400. And if you subtract them, I'll try doing this mentally, you'll get something like 9605 9601. 9605 9601, that's your answer.